All right, the next lesson, 7.4, solving proportions. What is a proportion again? Oh, you all better get this or I'm going to give you a quiz right this second asking you what a proportion is.
It's equal ratios.
Thank you. Equal ratios, right? Ratios that are equal form proportions, right? Anyway, notice yesterday's questions looked like this. And they had a comma, and they wanted to know if that was the same as this. Right? Are those the same?
No.
Are those ratios a proportion? No. This is times 5. This one is times 10. Definitely not a proportion, right? That was yesterday's. They were asking you if something was a proportion. Today, you're going to be solving proportions. Whenever you have something like this, I'm aware that you all know the answer to this. I'm not. This is a proportion. How do you know that it is a proportion? How do you know it's a proportion? No. How do you know that it's a proportion? How do you know that those two ratios are equal? Isn't that what a proportion is? Is when two ratios are equal? How do you know it's a proportion? No. How do you know it's a proportion? Nope. You do. These two ratios form a proportion. How do you know that they are equal to each other? Because there's an equal sign telling you that they're equal. Right? Doesn't that equal sign tell you that 2/5 equals x over 10? Is it asking you if they're equal? Does an equal sign ask you if they are equal? No. They're telling you that they're equal. Right? Therefore, ratios that say they're equal to each other are proportions because that's what a proportion is. Equal ratios. So it's not that we're asking whether or not it's proportional or not, whether or not they form a proportion. We're asking, well, what do you think that we're asking? What's x, right? We're solving this proportion. We need to find out what x is. So, here's the deal. We could do this. We could solve this proportion the old way, my way, right? Line down the equal sign, and you would go, what's the next step? See if the variable's happy. Is he happy? No, he's not. He's happy. What? Who's with him? The 10. What's the 10 doing to him? Dividing him. What's the opposite of divide by 10? What is 10 times 2? It's 20 over 5, which is 4. Agreed? And it actually needs to be written like this, right? Variable equals number. That is my way of doing it. Can be done that way, no problem. Absolutely, there's no problem with doing that. I'm going to show you a much better way to solve a proportion. When it's a proportion, I'm going to show you how to solve it. Okay? Here it is. Actually, I'll leave that there so that I'll just rewrite it over here. I had 2/5 equals x over 10. I would think most of you knew that x was 4 anyway. Agreed? You all knew that? Okay. This is what you do. Okay. Here's the way you do it. Line on the equal sign. That never changes. This is what you do. You remember this? Do you remember when we did this here? What was one way of finding out if ratios were proportional? If I had 13/8 and I wanted to know if that was the same as 65/40, what did I do? What did I do? What's one of the ways that I showed you how to find out if they're proportional? If they form a proportion. Tell me. What was one thing I did?
Multiply. See if they multiply too.
How so? Oh, right. Well, that would be right. What's another way? I could go like this, right, and go, okay, I don't know. But these are big numbers. What's another way, Juna? Cross multiply, right? I could multiply this way and multiply this way. If they were equal, then that means that they were a proportion, right? So listen. We know that these are equal. We know that. Agreed? We know it. So then what will be true? When I cross multiply, the numbers will be the same. What is 5 times x? 5x. What is 2 times 10? Then we already know it was 4. But do you see now what you can do, what you're allowed to do? You cross multiply because they are equal. Since they are equal, you can cross multiply and solve it that way. Let's try another one. Let's try this. Couple of things you can do here, okay? Couple of things. One, anytime you want to, line down the equal sign, cross multiply. X times 6 is? 9 times 4 is? Agreed? Okay. Another way of doing this. Well, what do you see that you could do right off the bat if you wanted to? What do you see that you could do right off the bat if you wanted to? What could you do? No. I already said that. What else could we do? What's something else that could be done really quick that actually bothers me a little bit that they even wrote it like this? How about that guy? What's wrong with him? Right, you could reduce him. Make him divide by 2, which you could do in your head, and that would be 2/3. Agreed? So we have x over 9 equals 2/3. Now I have a question. What is true about this? We know that the top is times 3. Why do we know that? Because we're not finding out if they're equal. We know they are. So if the bottom was multiplied by 3, then the top is also multiplied by 3, right? Which makes the answer, what is 2 times 3? 6. We knew that. X equals 6. You see what I'm talking about? There's no one specific way to solve proportions. There's lots of ways to solve them. And each way is equally, will work the same. It's just some are easier to do than others. Right? Some are easier to do than others. If I have, 4/8 equals, x over 150. All of a sudden, that one's that one would be tough to do in your head. Unless, what? What can I do right off the bat to make this kind of easy? Reduce. 4/8 is 1/2. 1/2 equals x over 150. Well, what is half of 150? 75. You're done, right? You just did that you did that quick because you knew you were allowed to reduce that. Or from here, if you didn't know it was 75, 2x equals 150. Divide by 2, divide by 2. What is 150 divided by 2? 75. No matter which way we do it, it's going to be 75. Or 1/2 equals x over 150. How does the 2 become 150? Times by 75, times by 75. 1 times 75 is? Right? Make sense? Anyway. I'm going to give you a quiz here now, and there's no, we'll just see how it goes. So I'll give you a quiz. Here we go. Piece of paper. You'll need it. What happens if they give you a box like that? What does that mean? Just fill it in, right? It just acts like a variable, right? There's that one. Good one. I like it. 4 is a good one. 4 is a tricky one. Just letting you know. Here's a little quiz. The rules don't change just because things don't come out clean or smooth, or if things are very ugly. The procedures stay the same. So I'm going to show you. I want you all to put your pencils down and you can watch. Put your pencils down so you can watch. Are you all watching? Just because it's ugly, the procedures, the rules don't change. The first thing, on this one, you should very quickly have looked and noticed that, okay, how does the 3 become a 4? Oh yeah, it doesn't. You can't do it like that, right? Are you watching? Cross multiply. Are you allowed to cross multiply? Yeah. Isn't that the way you're supposed to do it? Mm-hmm. What is 3 times x? 3x. What is 5 times 4? 9. What do I do now? You tell me. Is the variable happy? Why not? Because we multiply by what? He's being multiplied by x. The x is who wants to be happy. What? Stop talking for a second. What's the variable? What is the variable? X. Is the x happy? Why is the x not happy? He's not alone. Who's with the x? The 3 is. What's the 3 doing to the x? Multiplying him. How do I get rid of multiply by 3? Divide by 3. Divide by 3. X equals. What do I do with 20 over 3? Technically, if you wanted to leave it 20 over 3, you're done. But you got to change it to a mixed number. So it is what? 6 2/3? I don't understand. So difficult. Is it hard? So listen, it is. 3/5 equals 4 over 6 2/3. That's true. That is simply true. X equals 6 2/3. Just because things are ugly, or they don't come out smooth, they don't come out clean, you still do the same procedures. When you were little, when you were in kindergarten, if I gave you 2 plus 1, could you have done it? Yeah. You know what to do. You go 2 plus 1 is 3, right? In 4th grade, when I gave you 2.14 plus 1.03, you as a kindergarten, you just said, you can't do that. What? I don't know what to do it. Does anything change just because things get ugly? Just because things look harder? Does the rules change? No. Nothing changes here, people. Nothing. Just because the answer ends up being uglier than you expected it to be, do you not still cross multiply? You still do everything the same? You do. Did it come out clean? Are you super excited about that answer because it came out like, no. But it's still the right answer. We'll jump down here to number 4 again just so we can see. Oh, actually, there's no time. Yes, there is. There's time. Do number 4 again, right now. If you didn't get number 4 right, do it right now. You saw what you do. The rules don't change. Do 4 right now properly. Here it is, number 4. Cross multiply. What is x times 5? 2 times 11? Is the variable happy? No. Why not? Not alone. Who's with him? What's the 5 doing? How do I get rid of that? Multiply by 5? Whatever you do to one side, you have to do the other. X equals, what is 22/5? How many of you got x equals 4 2/5? Thank you. You all know how to do it now. No matter how ugly it turns out, you know how to do it. The procedures don't change just because it's ugly. You all understand what I'm saying? So that's why you can always cross multiply and the answer will come out. If it comes out ugly, so you know how to do it. Your assignment, people. Your assignment. I know, I told you it was a short day. I must have been wrong, huh? I know. There's no way I'm not giving you homework. I have to. There it is.